Okay, thank you. Good afternoon, everybody. My name is Sean Mulligan, and I'm the founder and CEO of an Irish technology company called Vortec. And what Vortec does is we are delivering and developing the next class of technology to solve challenges in wastewater management. But just to take a moment, we are surrounded by nature. We are challenged by nature when it comes to our water infrastructure. And might it be that nature also has the solution? So in this presentation, I'm going to take in a little bit of a different direction. It's going to be in two parts. It's in the title, how we can harness nature and the vortex to solve stormwater challenges and wastewater treatment challenges. So I'm really delighted to be here at this event in Abu Dhabi, really at the heart of innovation and investment in this infrastructure. And that's because there's a real need for this infrastructure. We know we need it for economic growth, for public health, and of course protecting the environment. But what about also saving lives? This infrastructure, however, is challenged. We are now looking at rising populations, massive increases in the production of wastewater. Our urban environments, as we've heard today, are expanding rapidly. I think in Abu Dhabi, the urban area has grown by 1,700% in the last 40 years. So this is creating a lot of volume of wastewater and stormwater to manage, but at the same time, ironically, we have a water scarcity challenge that we need to look after. So there's a commitment to now starting to treat this wastewater for reuse. So to take you on a little bit of a twist, has nature provided the solution? What's on this video behind me is a classical natural vortex flow. And it looks chaotic, right? But in fact, it's actually very stable and very predictable. At Vortec, we can predict what happens inside this vortex. We can drop a particle and tell the speed of that particle, the pressure difference, and where it will go in the flow. When you create a vortex flow, you can create a very stable high-velocity increase, and that type of high-velocity increase is very, very effective when it comes to creating air-water flow properties. And that makes it really, really attractive for aeration, for example. So let's go back to the challenge. This is a typical city, and we may in the city have a challenge of increased wastewater production and increased stormwater production. And the existing current infrastructure is just now unable to cope with that increase. So the solution, as we've already heard today, is that we need to drop it deep into deep tunnel conveyance infrastructure, deep below the city. And then we rely on gravity to do the rest of the work, to bring it to the treatment plant, and bring it back up to the surface for effective and sustainable treatment. These tunnel systems are being deployed all over the world. We worked on a project with the London Thames Tideway project, for example, with up to 30+ wastewater treatment drop structures. We heard about the Dubai strategic sewerage tunnel system earlier in the talk. And in Hong Kong, very significant stormwater infrastructure with flow rates of up to 210 meters cubed per second have been built. The challenge, however, is when you uncontrollably release this water through a deep drop, the energy contained in that water is absolutely significant. It's explosive and it can do significant damage if not controlled. In fact, we've done some analysis and it shows that even a small drop structure, the energy dissipation is equivalent to that of detonating tons of TNT every hour. So how do we manage this? How do we manage the chaos? Well, we do what nature does, and we organize the flow. We create a vortex. And a lot of you in the room will be familiar with this type of technology called a vortex drop shaft. And what we do to take this uncontrolled flow and get it organized, we convey it into a vortex generator. What the vortex generator does, it allows us to speed up that water. And then we convey it into a drop pipe. Now a particle of water, as it moves into the drop pipe, is at high velocity speeds, and it exhibits a centrifugal velocity, or centrifugal force. And as it's traveling down this drop pipe, it stays on the drop pipe, and the high velocity and frictional effects result in very, very effective energy dissipation. We're talking up to 70 or 80% of that originally explosive energy is now dissipated in the drop structure. So this is what enables the sustainable development of deep sewer systems. The flows are relatively complex, so we need to use technology and tools to assess the performance of these systems. This is computational fluid dynamics on the left, but also we need to sometimes combine that with physical modeling to really provide insights and de-risk the designs to get it to a place where we can be very, very confident in the long-term operation of that infrastructure for the next 100, maybe 150 years. So what I'm really excited to talk about now is what's on the left-hand side of the screen. We've now managed the stormwater and the wastewater, but now we have to deliver to a treatment plant where there's a whole host of new challenges. The main challenge primarily is we have huge volumes of wastewater that we need to now get to a better quality standard to enable water reuse. So we now have to do more treatment of more volumes of wastewater in existing agent infrastructure. And if you look at a traditional wastewater treatment plant, the heart of the treatment process is biological treatment, as a lot of you may know, using the aeration process. And on the screen behind me, you have what might be considered the first generation technology for aeration. It's called surface mechanical aeration. And the good thing about this technology is you can touch it, you can access the technology. But that's because you also need to maintain it. And it's also energy intensive. Then you might have what's called the best-in-class technology, which is fine bubble. And the fine bubble is effective because it's efficient. However, the challenge is how we deliver that fine bubble today. We do it at the bottom of a tank through a diffuser. And diffusers inevitably clog, they foul, and eventually they break. So in many ways, it saddens me to believe that we're doing all this effective innovation and investment in the steep sewer system to bring the water to a tank where we have over 1,000 potentially failure points for that system. But what if we could generate the same fine bubble that makes FPDA systems so efficient, whilst eliminating the complexity and the maintenance headaches that associated with other types of maintenance-based, surface-based technologies? And that's what Vortec have done. We've harnessed the power of the vortex flow to get the best of both worlds. This is a new class of technology called vortex-powered aeration. And essentially what we're doing is we're taking that same flow phenomena that I showed you in the video, and we're compacting it into a single piece of product, which is shown here on the screen behind me. We're pumping the water, the activated sludge, into a vortex. We're spinning up that velocity, that fluid, at a high speed. And as I mentioned, we can get some amazing air-water flow properties. So we can generate significant amounts of air entrainment without the need for blowers, or civil works, or blower rooms, or pipe work. The air and water is mixed together and it creates a fine bubble plume, and as you can see in the computational fluid dynamic simulation, we can create full mixing and oxygen transfer across the depth of a tank with the solution. But best of all, the solution can be fitted to the top of a reactor, so it can be accessed, and the overall aeration system can be maintained within 20 minutes by accessing a single hatch and lifting the pump for inspection. This technology has been proven. We have technology adopted with the leading utilities in Ireland, in the UK, and more recently in Australia. This year we will do a 250,000 population equivalent upgrade. And we've also coupled this technology with the latest digital solutions. So we can predict maintenance, we can predict biological system health, and we want to get this to a place where artificial intelligence is going to be able to optimize in real time the overall biological process to ensure the maximum efficiency and sustainability. The benefits are very clear. We can install much quicker than conventional technologies. We reduce energy, we transform maintenance. But most of all, we have designed this technology like the vortex drop structure. We designed it to last. So these benefits are more consistent and last twice as long, ultimately significantly reducing your total life cycle cost of your wastewater infrastructure. So, where I started was, can nature help us? And we're confident that nature has at least helped us with one problem, and that's being able to manage stormwater and also treat wastewater. John, my colleague, and I have an exhibit outside. We would love to take the time to talk to you about your projects and share the insights that we've gained from this exciting area of technology development. Thank you very much for your time.